Hello and welcome to Megagon Lab's sponsor session at SIGMOD 2022. I am Esteban Rushka, and in the first part of this presentation, I'll briefly introduce our research lab and our contributions to SIGMOD 2022. Also, in the second part of this presentation, Julian, who is a senior research scientist at Megagon Labs, will give a brief overview of one paper that our lab has at SIGMOD main conference and two other papers that our lab will be presenting during SIGMOD at the workshops AI, DM, and DIM. At Megagon Labs, we empower people with better information to make their best decisions. We produce high-quality research and advance the state-of-the-art on artificial intelligence, natural language processing, data management, machine learning, and information extraction. We focus on different problems related to experience discovery and search, data analytics and exploration, knowledge discovery and representation, and data preparation and integration. We are located in two offices, one of them in Mountain View, California, in the US, and another one in Tokyo, Japan. We are an innovation hub of Recruit Holdings. Recruit is a Japanese company founded 1960, and it has more than 51,000 employees, more than $28 billion revenue, and more than $60 billion market capital. Recruit Holdings provide over 200 online services and owns 351 subsidiaries worldwide in the areas of human resources, travel, housing, education, restaurants, and many other in which people make daily lifestyle decisions. Some subsidiaries from Recruit Holdings are Megagon Labs, Indeed.com, TrustU, Glassdoor, CSI Companies, Pandu, and many others. During SIGMOD 2022, Megagon Labs will present 3 different papers, one in the main conference and 2 in the workshops AI, DM, and DIM. Megagon Labs is also contributing to the New Researcher Symposium, where we have Xiaolan Wang, our senior scientist, as a co-chair of the event. Now I will invite you to hear from Julian about the papers that we have at the conference.
This year, Megagon Labs will present 3 papers at SIGMOD, Duo, MacChop, and Mina. Nowadays, machine learning is playing an increasingly important role in data management tasks. This is also the case for data integration and preparation. In general, Megagon Labs is interested in applying machine learning or deep learning techniques to solve tasks ranging from information extraction, integration, and data cleaning. Given the source datasets such as the corpus of raw text or HTML tables, we would like to first apply information extraction to annotate, for example, the semantic type of each column or the relations between pairs of columns. We will present our multi-column and multi-task model Duo for these 2 tasks. And next, we want to integrate the incoming datasets with existing structural tables, so we need to perform schema matching or entity matching. We will present a deep learning solution MacChop to solve a generalized version of the matching task. We also present a framework called Mina, which enables us to not only perform high-quality matching, but to make the matching results explainable. So next, I'll present our first paper, Duo, which is about annotating columns with retrained language models. Today, we store any types of information in table formats, and there is a large number of tables available on the web, at enterprise data lakes and anywhere else. This large number of tables creates the opportunities to integrate information about certain topics and search over the tables. However, one challenge is that these tables are made by different developers for different purposes, so schema structure may not be always aligned with each other. Predicting the meta information about the tables can help us address the issue, and that's why it is an active research topic in data management community. In this paper, we are interested in 2 tasks, column type prediction and column relation prediction. For example, here we have a table about animated movies. The column type prediction task is given column values to predict column types that describe the semantic information of these columns. In this example, the column type should be film, director, producer, and country. Similar to column types, the column relation prediction task is to predict relations defined between a pair of columns. In the right table, those relations provide more fine-grained information about the table, and now we can understand what the location is about for a person by assigning place of birth relation label for the column pair. We designed Duo to leverage the strong language understanding capabilities of retrained language models such as BERT. Language models are typically large transformers of retrained on large text corpora such as Wikipedia. Once it is retrained, it can be fine-tuned to many downstream tasks and sometimes even achieve close to human-level performance. To leverage retrained language models to table understanding, we first need to convert tables into textual format by serializing the columns into sequences of tokens. For example, if we want to perform column type prediction, we can concatenate all values of a column into a single sequence by adding the special tokens CLS and SCP. Thus, we expect that the language model to generate a contextualized embedding on ECLS, which ideally capture the meaning of the entire column. We can then fit this vector to a linear classifier to classify the column type. So far, the single column model only makes prediction based on the column itself without any context. And to take the column context into account, we designed a multi-column model that serializes all column values in the same table. And also by attaching output layers to the contextualized column embeddings, we can now predict the types of every column in the same table simultaneously. You may also notice that the column type and relation prediction tasks are strongly correlated, as features useful for one task are also useful for the other. This motivates us to design Dudo, a multi-task and multi-column solution for both column types and relation prediction. We attach different output layers and fine-tune the same model using training data from both tasks at the same time. And by doing so, we avoid fine-tuning two language models separately and can leverage training examples for one task as auxiliary signals for the other to achieve better performance. We evaluated Dudo at two table benchmarks, Wikitables and WisNet. For both benchmarks, Dudo established new state-of-the-art performance on both tasks by outperforming previous best methods on TURL and SATO by a significant margin of up to 9% micro F1 score. And we have more results in our paper, including a real use case of using Dudo for table clustering in a private enterprise data lake. In summary, Dudo is a multi-task, multi-column model based on pre-trained language models. In our experiments, Dudo achieved new state-of-the-art results of column type and relation predictions, and more results in the paper shows that Dudo is also data efficient in terms of the input lengths and training examples. You can check out our code and models available at this link. Next, I will present Matchup, an end-to-end generalized entity matching framework, which we will present in AIDM this Friday. Real-world applications nowadays frequently seek to solve a generalized form of matching problems, such as matching students with courses, customers with products, or matching job seekers with companies. Unlike classic entity matching, this new problem, which we call generalized entity matching, can have entities of different types, heterogeneous data formats, or general binary association, such as whether the candidate is qualified for the job. It turns out that this problem is challenging. So in this example of matching jobs with resumes, both the job and resume have the same title of a nurse practitioner, but they're actually not a good match given the text overlapping. The reason is that the job description requires a nurse of a special experience in level 3 neonatal intensive care unit, which the resume doesn't have. In order to make this non-match decision correctly, the system needs to have strong language understanding capabilities to detect, for example, MSN degree is compatible with a Master of Science in Nursing and the semantics of all these different items. The system also needs to understand the structure of each document. For example, education and certification should be matched to education and skills. As you can tell, this task is very challenging even to the state-of-the-art NLP and matching solutions. To address these challenges, we propose an end-to-end framework called Matchup. And in a nutshell, Matchup performs accurate matching by incorporating pre-trained language models such as BERT to a classic entity matching pipeline. In order to apply language models for matching, we first need to convert the input to text sequences. Again, we serialize this entry into a string like this by inserting special tokens COL and VAL to indicate the start of attribute names and values. After that, we can concatenate the two serialized entities into a single sequence to perform sequence pair classification. And by adding the task-specific layers on top of the model, we have a baseline solution based on fine-tuning. The default fine-tuning setting provides a good matching baseline, but we can further improve its performance by addressing two key challenges. The first challenge is that language models typically have a max sequence length, but job targeting tasks can have long sequences of more than 1,000 tokens. Simple truncation can fail because the key matching information, such as qualification, are oftentimes hidden in long and less relevant text. To address this challenge, we propose an optimization based on attribute-aware summarization. We train a sentence classifier that assigns one of these 6 topics, qualification, benefit, duty, etc., to each sentence in the job description. And for each topic, we apply summarization operators such as truncation to shorten each text. We can apply similar operators on the resumes to summarize each resume sections independently. And by doing so, we can guarantee to retain some information for each topic and section. The second challenge is that we want to better leverage the internal structure of the document. The default fine-tuning setting only uses a single special token to represent both input entities. And in Matchup, we propose a novel structure-aware pooling layer that applies sum or max pooling operators over the element-wise attribute similarities. By doing so, we can explicitly compare sections and topics within the documents, such as qualification versus experience, and aggregate their similarities to guide the language model to obtain better representations. We evaluated Matchup on 2 job targeting tasks, job-to-job matching and job-to-resume matching. For job-to-job matching, the goal is to retrieve pairs of similar jobs so that we can recommend relevant jobs to the users. As we can see, Transformers model like BERT outperform classic machine learning methods like SVM by 7%, and Matchup significantly outperformed the previous best model BERT by over 10% on F1 score. For the job resume matching task, we use the same set of job descriptions and 700 synthetic resumes created by experts. We can see a similar trend that BERT outperforms SVM by over 11%, but our pooling and summarization techniques further improve the performance of language models by a large margin of 15 F1 score. And in summary, GEM is a challenging task, and Matchup based on pre-trained language model is a promising solution. Our optimizations, including attribute-aware summarization and pooling, further improve its performance on top of BERT. So you're welcome to join our live presentation in AIDM this Friday. Finally, I'll present Minam, a framework for counterfactual explanations for entity matching. So this paper will be presented in DIN on Monday by my colleague Jim. We have seen that using deep learning models such as transformers can achieve promising results in data integration and preparation, but their good performance also comes with the cost of being too complex to interpret, unlike rule-based or classic machine learning models. However, in many applications such as job resume matching, in addition to have a model that can correctly predict whether the input pair matches or not, we also would like to know why the model makes a certain prediction, whether it is based on education, skills, benefits, or it is using any biasing features such as gender, company, or university names. There has been techniques proposed in explainable AI to address this challenge. Intrinsic or model specific methods use the model's internal parameters as interpretation, but they typically only work for certain models and cannot be generalized. Post-op methods such as LIME or SHARP are model agnostic and only treat the model as a black box. They train an interpretable model such as a linear classifier using locally perturbed examples. But however, in practice, we found that LIME and SHARP didn't provide good quality explanations for textual data and oftentimes ran too slow. Therefore, in MENUM, we consider another line of solution called counterfactual explanations. For given example x, a counterfactual explanation provides a variant x prime close to x, such that the model predicts differently. These explanations provide the insight that if an event x had not occurred, then an outcome y would not have occurred. Based on this idea, we can come up with baseline counterfactual explanation, such as removing spans or name entities from each record to highlight the important spans, or we can equalize some attributes from both entities to explain that the two records do not match because the attributes does not match. With these two baselines, we still found that the coverage is relatively low, meaning that we need more complex explanations. To achieve this goal, in MENUM, we propose a search space of counterfactual explanations based on attribute-aware at a distance. We propose two algorithms, one greedy and one based on binary search, to traverse the search space. You can check out our paper for more details. Now we have different explanations from different methods such as LIME, SHARP, or MENUM, but how can we compare different types of explanations, especially when they have different formats? This is indeed a major question not yet fully answered by the XAI community. Inspired by a recent trend of work in NLP, we propose an evaluation framework based on the simulation process of having a student model to simulate the target model or the teacher. We ran the simulation in 2 rounds. The first round is a regular training loop without the explanations, and the second one is with the explanations. And by doing so, we can qualitatively evaluate the quality of the explanations by comparing how much the student model is improved by taking the explanations as an auxiliary input, or in other words, how much insights a student can learn from the explanations. Under this evaluation framework, we compare MENUM with 3 baseline methods, LIME, SHARP, and the baseline counterfactual explanations. We found that MENUM indeed generates higher F1 score improvements, and our analysis also shows that the performance gain is due to the higher percentage of counterfactual examples given by the edit distance search space. In summary, MENUM is an explainable entity matching method based on counterfactual explanations. We also propose an evaluation framework allowing comparison of entity matching explanations of different types and formats. Our initial results show that MENUM provides higher quality explanations and being more time efficient. You can check out our call at this link, and you are welcome to join our live section at the. Thank you.